A customer says the network feels slow. That single sentence, however sincere, cannot be fixed as written. There's no threshold in it, no owner, and no way to know afterward if it actually got better. Vague complaints like this one are common, and they share the same flaw. A feeling has no number attached, so two people can disagree endlessly about whether it's actually a problem. The fix starts with measurement. A latency probe begins recording the actual completion time of every real request crossing the network, continuously, second by second. That raw measurement immediately splits into two very different stories: the typical, everyday request and the worst-case tale that a small fraction of users actually experience. Against that measurement, the team sets a service-level objective, and SLO, a specific number they've agreed defines fast enough for this particular service. Underneath that objective sits an even more precise definition, the service-level indicator. Exactly which requests count, measured exactly how, so there's no ambiguity later. And once that target exists, it can trigger real action automatically, an alert the moment reality drifts past the agreed line, no meeting required to notice. A vague complaint measured, split into typical and worst case compared against an agreed number. Let's follow exactly how that number gets built and used in slow motion. Take 1, the network feels slow arrives as a support ticket, and without a number attached, it can't be assigned, prioritized, or verified as fixed. It's simply not actionable yet. So the reliability team turns to the latency probe already running across the network, sampling the actual time every real request takes from start to finish. The first number that comes back is the median, commonly called P50, the point where half of all requests finish faster and half finish slower. Here, that's 40 milliseconds. 40 milliseconds sounds perfectly healthy, and for most users, it is. But the median hides exactly the kind of pain a small fraction of requests are actually experiencing. That's why the team also tracks P99, the worst 1% of requests. Here it comes back at 210 milliseconds, more than 5 times slower than the typical case. That tail matters disproportionately because it's often the same unlucky users hitting it repeatedly. A slow retry path, an overloaded link, a specific route through a specific data center. The team already has an SLO defined for exactly this metric. Keep P99 latency under 200 milliseconds, agreed on months earlier by engineering, support, and leadership together. Underneath that target sits the SLI, the precise indicator definition. Which endpoint, which region, measured from which point in the request path, so the number means the same thing to everyone reading it. Comparing the measured 210 against the target 200 produces an unambiguous verdict. The SLO is missed by a real, specific 10 millisecond margin. Because the target is codified, not just discussed, an automatic alert fires the moment the miss is detected. No one has to notice a vague slowdown by accident days later. An engineer picks up that alert with a genuinely useful starting point. Not the network feels slow, but P99 latency exceeded 200 milliseconds in this specific region, starting at this specific time. That precision turns a hard-to-start investigation into a tractable one. The engineer traces exactly which hop in the path is adding the extra 10 milliseconds. Once identified and fixed, the same probe reproves it immediately. P99 latency drops back under the 200 millisecond target, measured, not merely believed. And because the number is shared across the whole organization, everyone, the engineer, the support team, and leadership, reads the identical fact off the identical dashboard. The distinction between SLI and SLO matters more than it sounds. The SLI is the precise measurement itself, while the SLO is the target line drawn against that measurement. Confusing the two causes most disagreements about whether a target was even met. Percentile choice is itself a deliberate decision. Some services track P99, 9 instead of P99 because at massive scale even one request in 1,000 can represent thousands of genuinely frustrated users per day. SLOs are typically set a notch stricter than any external promise, the SLA a customer contract guarantees. So the team gets its own early warning well before it's ever in breach of an actual contractual commitment. The honest trade-off, choosing the target itself, is genuinely hard. Too strict, and the team pages itself constantly over noise. Too loose, and real degradation slips past unnoticed until customers complain again. Measure every real request, split typical from worst case, compare the worst case against an agreed target, then let a genuine miss trigger real, specific action. That's turning fast enough into a number. That's the whole trick. Next time someone says a service feels slow, you'll know exactly which number should answer that question instead. Check out our other videos and follow how it all runs for more. See you next time.